Hello everyone, welcome back. This is Engineer Hussein Wasapi. So in this video, we'll be looking at the question that was presented in chemistry as it is, as you can see. So basically, before we begin, don't forget to like and subscribe to the channel. So the question reads to say, all experiments, no matter how meticulously planned and executed, have some degree of error or uncertainty. In chemistry 111, laboratory experiment 2, you learned how to identify, correct, and evaluate sources of error in an experiment and how to express the accuracy and precision of measurements when collecting data and reporting results. Now consider the following. You have 8 students who were asked to record the volume of a liquid placed in a biuret. The following readings were recorded in the table as you can see. So you have the number of students that have been given as 8 and the volume as it is. So you have been asked to define the following terms. So basically we have A, which asks us to define the following terms, of which the first term is basically the term which is error. So what is error? So error is literally defined as the difference between the measured value and the true value of a quantity. The difference between the measured value and the true value of a quantity. That is what we call as the error. So the difference between the measured value and the true value of a quantity. The true value of a quantity. So basically, that is the definition. And then we have number 2, which says precision. So when it comes to precision, there are quite a number of ways you can define precision, but the best definition I can give you right now is defining precision to be the degree to which a number of measurements are reproducible. Or rather, I would say it is the measure of the reproducibility of a result, or let's say how frequent a particular degree of numbers are coming close to each other. When I say close, of being repeated rather. Yes. So I think that's the best way. So let's say it's a measure of the reproducibility of a result. So let's use that. The measure of the reproducibility of a result, just like that. And then we have the third one, which is basically accuracy. So accuracy is how close the measurement is to the true value of the quantity being measured. So we're talking about something being close, isn't it? So how close a measurement is to the true value. Of that particular quantity that you're measuring, to be precise. All right, so be mindful of everything that I've looked at. So we have defined error, which is a difference between the measured value and the true value of a quantity. We've also defined precision, which is the measure of the reproducibility of a result. Then also defined accuracy, which is literally how close a measurement is to the true value of the quantity being measured. All right, now if you look at part B, this one here, it says state and explain the types of errors experienced during experiments. Now, what type of errors are there? We need to explain and state them. So basically, we can start with the first error that is quite common, which is called the human error. Human errors. So now, what are these human errors? So now, these human errors are basically the errors that occur due to the mistakes made by the experimenter, such as maybe misleading a measurement or maybe recording something incorrectly. So they can be reduced by maybe carefully paying attention to the details and double checking whatever that you have measured. So basically, human errors are these errors that occur due to mistakes made by the experimenter. Yeah. Errors made due to mistakes made by the experimenter, which is the person conducting the experiment. Then secondly, we can look at the next error, which is systematic errors. So what are these systematic errors? Systematic errors. So systematic errors are basically the errors that occur due to a flaw in the experiment design or equipment. And this can be reduced by maybe if you identify or correct the source of the error that is at hand. So in a nutshell, you can say errors that occur due to flaws in experiment design. So errors that happen due to a flaw in the experimental design. All right, let's look at the last one. The last one is called the random error. The random error. So now what are random errors? So random errors are basically those errors that occur due to like I would say the unpredictable fluctuations in the experimental conditions. And then the only way you can reduce these is maybe by taking multiple measurements and maybe finding the average results of everything given. So random errors are basically errors that occur due to unpredictable fluctuation in experimental conditions. So we're saying that these are errors that occur due to unpredictable fluctuations in experimental conditions. All right, so that is that which you have to know about the terminologies we have at hand. So basically, one should know what error is, what precision is, what accuracy is. You should also be able to state and explain the types of errors that can always be experienced in an experiment. I've given you human error, systematic error, and random errors. So these are type of errors that are quite common, and probably most of you are aware of them or are already familiar with them. All right, let's jump to C and see what we can do. All right, so basically C says calculate the average mean value of the volume of the gas in the table. Calculate the average mean, or let's say the average, which is the mean value rather, of the volume of the gases in the table. So to find the mean, X bar, the mean is the sum of the volumes. So it says sum of the volumes divided by total number of what? Volumes, which are basically like the attempt volumes that you have rather. So it's basically you adding up everything. So you have like the mean being equal to 26.05 plus 26.18 plus 26.30 plus 26.20 plus 26.27 plus 26.17 plus 26.22. Okay, the space did not assist. So say plus 26.22. And the output of this to be divided by the number of attempts. So we have 8 attempts. 1, 2, 3, 4, 5, 6, 7, 8. 8. So if you sum up all these, if you say 26.05 plus 26.18 plus 26.30 plus 26.20 plus 26.02 plus 26.27 plus 26.17 plus 26.22. What are you going to get? So you will get something like X bar being equal to 209.41, and you divide this by 8. So if you divide this by 8, you end up having your value to be 26. So this will give you the mean value as 26.17625. So basically your mean is 26.18. Just like that, you will have your mean in milliliters. All right, so they're saying assuming that the true value of the volume was 24, 0.04 milliliters. Calculate the relative error. Okay, so it's been a minute ever since I did some relative error questions. So assuming that the true value of the volume is that, calculate the relative error. So we know the true value. The relative error as a formula where you say mean minus true value divided by true value. So we're saying relative error is equal to mean minus true value divided by true value. Then the whole lot of this is multiplied by 100%. So this simply means that you have the mean, which is 26.18, minus the true value, which is 24.04, divided by the true value again, which is 24.04, and then this is multiplied by what? 100%. So if you do your basic computation there, you say 26.18 minus 24.04, you get something like 2.14. Then if you divide that by 24.04, which is a true value, then multiply by 100, you will get your answer to be approximately 8.9. So this would be 8.90%. So this will be our value for our relative error. So since it's relative, it will not really have those units, but it will be in a percentage form rather. And then they're saying calculate the absolute error. So the absolute error is just equivalent to the mean minus the true value. So absolute error, so error absolute is equal to mean minus true value. So the mean is 26.18 minus true value, which is 24.04. And be mindful, this is the absolute form. Even that should be the absolute form, because the relative error is simply basically equal to the absolute error divided by the true value times 100%. That's another way you can actually phrase it. So if I say 26.18 minus 24.04, I'll basically get my absolute error to be equivalent to 2.14. So this would be 2.14 milliliters as my final value for my absolute error. So basically that's how I go about solving those questions. Now they're saying comment on the accuracy and precision of the data obtained by the student. So the comments on the accuracy and precision of the data obtained by the students is in such a way that if you look at the data obtained by the students, you'll find that it's actually precise. Okay, comes to precision, so we say it's precise. So measurements are precise. So measurements are precise. Due to the closeness of what? Values. Due to the closeness of values. This is not really accurate. So measurements are not accurate. They're not accurate. Anyway, this is how you go about solving such questions. If you have any queries, you can reach out to me on WhatsApp on the 9077 149 5252. Remember, slow progress is better than no progress, and don't forget to strategize before it becomes a statistic and try and push for that A+.